Thermoluminescent dosimetry is broadly understood as the most extensively used in radiation dosimetry and is definitely a common method for routine measurement in radiation exposure. The process that thermoluminescence material undergo irradiation which absorbs energy, produce free electrons and holes, and consequent thermal stimulation results in the assumption of assembled energy in the form of light, which referred as TL, thermoluminescence. Phototransfer thermoluminescence, PTTL, by simultaneous stimulation of UV irradiation and heating, the residual signal that is not lost by TL reading can be read out for a second time. In this project, I'm trying to study the relationship between thermoluminescence and phototransfer thermoluminescence of borosilicate glass light, and to see how the dependencies of TL signal affect the glow curve and the efficiency of PTTL method. Note that the efficiency of PTTL is defined as a percentage based on the ratio of the second reading to the first TL evaluation of exposure. Sample that were used in this project is borosilicate microscope glass light. The entire measurement cycle for this project consists of the following steps: sample preparation, gamma irradiation, first readout of TL signal, UV irradiation, second readout to collect the PTTL signal. By using energy dispersive X-ray (EDX), the elemental composition of the sample can be identified. According to the data generated by EDX analysis, the highest atomic percentage in the sample is oxygen, 49.13%, followed by silicon at 20.57%, boron at 10.61%. Based on our research, glass containing 7 to 13% of boron oxide is known as low borate borosilicate glass and is mainly used to produce chemical apparatus. There are three parameters studied in this project. The first one is dose response. The increase in TL and PTTL response with dose remain linear over a wide range of values of dose. The results are important that it is desirable for the measurement system to produce a linear TL response in the range of the decided doses. However, the efficiency of PTTL is decreasing as the dose increase. Secondly, maximum readout temperature. Further apparent is that at lower values of maximum readout temperature, the reduction in the number of the occupied traps occurring during the original TL readout has left sufficient numbers populated for there to be appreciable PTTL. This is entirely in line with the expectation that in decreasing the maximum readout temperature, an increase occurs in the percentage efficiency. And the third one is UV exposure time. It is to be expected as the longer the exposure to UV radiation can remove greater electrons in the deeper traps, and the PTTL efficiency seems to decrease as the UV irradiation time increase. This may be due to optical bleaching or fading of the trapped electrons. For borosilicate glass, a broad peak structure is observed where peak maxima occur at temperatures within the range 200 degrees Celsius and 300 degrees Celsius for all doses, and the curve started to rise up at 100 degrees Celsius. The causes of the broadening of the glow curve can be categorized into two aspects, which are inhomogeneous broadening due to different localized defects in disordered glass, and homogeneous broadening due to the coupling of electronic transition to photons. Experimental result shows that the use of UV lamp produce PTTL signal from borosilicate glass light that is sufficient in order to allow re-evaluation of dose from previous TL readout. Low maximum readout temperature are needed in order to gain the greatest efficiency of PTTL method. The present work shows that as borosilicate glass light subjected to cobalt-60 irradiation, a linear dose response has been obtained upon exposure to absorb dose from 2 gray to 200 gray. The rate of phototransfer depends upon the maximum readout temperature, pre-gamma irradiation, and also the time of UV irradiation. This method should be further investigated as the means of dose re-evaluation towards optimizing the glass light sensitivity and reproducibility, perhaps also with other dopant concentration, and also at doses down to a centigrade or less, where more substantial demand for its application might be expected. That's all for me. Thank you.